Hi, good morning, and thank you for joining me in my shop. Today is March 9th already, and I may be mistaken, but today the temperature may go above freezing. It's either today or tomorrow, and then it's going to stay above freezing during the day. Maybe for good. Maybe the frozen days may be over. That would be nice. So today what I plan to do here is test the vacuum tubes. I really don't think any of them are going to be bad, but you never know. And the radio's behavior is a little wonky, and I think I should eliminate that as being a potential problem, and replace any of the tubes that are shot. These are pretty old tubes. This is a pretty old radio receiver, in fact. So I'm going to test it on my 966 Stark tube tester, very popular tube tester here. I don't know about elsewhere, but there's a lot of these floating around here in Canada. Pretty sure, yeah, made in Canada by Stark Electronic Instruments. This has always been my go-to tube tester, although if you've watched lots of my videos, you know I have a lot of tube testers for no good reason. I hide them from my wife. So she doesn't realize how many I really have, because she's going to ask that question. What do you need all those for? That's a tough question to answer, in fact. Okay, I think we're going to start with the number 80, but really I have to go turn on my coffee machine. I just realized I haven't turned it on yet today. Okay, first tube is going to be the output tube, the tube that drives the speaker, and this is a 6F6, excuse me, and you can see it's gray. There's some kind of coating inside, on the inside of the glass. And actually, I don't really know what it is. I'm familiar with tubes that are coated on the outside, and that's just a shielding. Coated on the inside like this, I actually don't know why. And if you look, you can see bits of the coating have been knocked off. Like, see those black dots? That's actually that's actually areas where that gray coating is missing on the inside. Now, how that would happen, I don't know. There's something loose in here. I'm shaking it around. Well, I don't hear anything, but sometimes there are loose things floating around inside these tubes. I'm sure it's not a good thing. Okay, 6F6. So I'll let you watch the whole process in case you haven't seen how something like this is done. But, it looks more, well, in today's world, I was going to say it looks more fancy than it really is, but does it look fancy? I don't know. I think it looks old. 6.3. So I've dialed up 6F6 here on the roll chart. JR, those are the heaters. 5347. 5347. With a 2 at the end here. So each one of these is selecting a function to go to one of the pins. So for instance, if you can see the word, you can't see the word. It says plate, screen, cathode, suppressor. So on this tube tester, you're setting these to send this kind of circuit to the correct pin on the tube. That's how this one works. It's not so mysterious as many others. We're at 6.3 and I have the filament done right. And you go. Still have to do a couple more settings here. The bias setting is 29 and 73. If we care to use the English scale. We set this to English. We'll use the replacing good English scale. So this tube, brand new, would register 2000 on this meter in this tester. So I have the scale selector set for 3000 full scale, so 2000 would look like that. That would be brand new. By the time it wears out, it gets down to 1260. 1260 is about here. It's time to think about throwing it away. In today's world, no, we don't throw them away. We don't throw them away till they don't work at all, till they're dead. And even then, personally, I don't throw them away. I have a box. I have a big box with hundreds of dead tubes in it. I don't want to throw them away. Don't know why. But 1260 would be the point where we'd start wondering. Now, we've heard some sound coming out of this radio, so for sure this works. By now, it's fully heated up. So first test is to look for any shorts. If the elements in the tube have fallen together, which can happen, and there's a short circuit in there, You don't want to apply a test. If there is a short circuit in there and that tube was in the radio, and I was using the radio earlier, that can't be a short circuit. Well, let's look. Watch for the short light. So it flashes, but that's fine. It's if it stays on. It did not stay on. So we're ready to do the actual test. P4, the red button, 1260. Well, look, it's at 2000. So according to this tube tester, that's as good as new. It could be. It could be. It's virtually new. We don't know the history at all of this radio. In any case, this tube is good. Okay, now we're gonna leave the sort of the audio end of it. We're gonna go right back to the start, the very first tube in the circuit here. And this is a 6J8. Let me just make sure I've got that on this tester. Yep, 6J8, two tests. Heptode and a triode inside this tube. Now, get the grit cap off without blue. Yeah, what are you doing? What are you doing with the screwdriver? Well, you'll see something unusual about this tube here. There we go. Yeah, normally I wouldn't stick a screwdriver at the top of one of these tubes. Try it, but look at this one. I need a bigger screwdriver. So what I'm trying to do here is I'm trying to avoid using the glass to pull the tube out. It's not going very well. Wow, I'm just holding this in. Because I can't get a very good grip on it. Wow. The sound you hear in the background, that paper sound, that's my cat behind me. Oh my gosh, I've never had a tube held in so tightly. Wow. What's going on with that? Nothing. It also has the coating sprayed inside it. I really wonder what that would be. The coating I'm referring to. Let's try a little experiment here. My browser just updated today, and it wants to talk to me. Let's see if we can talk to it. We'll try it this way. And of course, I'm talking about talking to AI. Use Alt space to talk to Copilot anytime on your PC. Okay, I've turned it on. Alt space. Keep using the Copilot. Keep. Good morning, Copilot. How you doing today?
Good morning. I'm Copilot. We can chat about anything and everything, just like you would with a friend. What's on your mind today? And what's your name?
My name is Jim, and I'm testing vacuum tubes on an old tube tester.
Nice to meet you, Jim. Old tube testers can be pretty fascinating. It's like a trip back in time. How's it going with the testing?
Testing's going fine, but I have a question about one of the old tubes I have.
Shoot, what's your question about the tube? I'm here to help.
Okay, so the tube is a 6J8E. It's a glass tube. Has a grit cap on the top of it, but it has a gray coating on the inside of the glass. What is the gray coating?
That gray coating inside the glass is likely getter material. It's used to absorb gases inside the tube, keeping the internal vacuum clean. The gray color usually means the getter has done its job and captured contaminants. It's a good sign.
No, it's not the getter I'm talking about. The getter, I can see it down below. This is a different gray material. like a almost like a shield on the inside of the glass, but I don't think it's a shield. Any idea what it is?
Got it. That sounds like it could be a metallization layer. Over time, some tubes develop a layer on the inside of the glass, caused by the evaporation of the cathode material or other internal components. It's generally a sign of a well-used tube, but doesn't necessarily mean it's bad. How's the tube performing?
Well, I haven't tested the tube yet. And no, that what you're suggesting is not what this gray material is. I know what you're suggesting about volatilized materials collecting on the glass. Now, this is a manufacturer's spray coating that they clearly put on very carefully on the inside of the glass. Not the entire glass, just this, I don't know how to describe it to you, the center part of the tube. So it's not completely covered inside. Any idea?
Ah, that sounds like it could be a form of shielding or a conductive coating applied during manufacturing. This can help reduce internal noise or improve the tube's performance. It's interesting how they applied it very precisely. These details give each tube its own character.
Okay, thanks, co-pilot. Talk to you later.
No problem, Jim. Catch you later.
Okay, I'm just... Is he still listening? Co-pilot, are you still there? No, I turned him off. Okay, well that was kind of fun. That's the first time I've ever talked to something like this, and I think I'm going to be doing this a lot from now on, because I've been using AI to explore kind of personal questions I have, technical questions I have, that I can never find the answer to. Very pointed, little minuscule questions. Come here, cat, you're going to cause a problem up there. And I get into conversations, but they've been typed up to this time. So from here on, I'll be talking. Okay, Wally. Now let's test this tube. Okay. 78E. Okay. 70. Oh, what am I? 78E. What am I saying? 6J8. I don't know where that came from. 6J8. 6.3 JR 5347 with a 6. 5347 with a 6. 18 on the bias, 50 on the English, and press B4. When I was in high school, this exact type of tube tester was in our electronics lab. Yeah, we had an electronics lab in my high school, which is unusual too. And I saw this English, and I know, what the heck is that? And what I concluded was, this is English, like you put spin on a ball, you put some English on that ball. That's what I thought this was. I thought this meant some kind of, I don't know, extra oomph, that you put some English on that tube test. But in case you don't know what it really means, there's a setting here called English. You do that, and then you just use the replacing good up here. That's what it is. Nobody was explaining anything to me at that time. We need a cap. I need a grid cap here. Okay. These tubes, like a 78, this is a rare, fairly rare tube. It's worth a chunk of money. $50 or something like that these days. Maybe more. Can't say I've really been checking out tube prices lately. Okay. There we go. Any shorts? No shorts. This tube and this part of the tube, we're doing part of the tube now. 1,000 like new, 630, throw it away. 1,000 like new, 630, throw it away. Well, it's in the 630 range, but we're not throwing it away. And then the next test, JR 5, 6, so 6 and 3. So we go, got the wrong one there, Jim. 6 and 3. Just double check. Yeah, change this to 30. For some reason that goes down to 0. And P4, press button P4. Now it's just just up here, and it's okay. Hardly has to go anywhere. It's perfectly good. So this tube is not a problem. It's a good tube. I was going to show you the grid cap here. So when I was prying with the screwdriver, just in case I was freaking people out there, I was prying at the top of the metal here. So I was prying the cap, the slip-on part against the cap, not against the glass. I was not prying down here. No, no, don't do that. Don't do that. Unfortunately, like for instance, if the grid cap glue gives out, which it regularly does, you're in a bit of trouble there. Might end up with just a wire sticking out the top here and have to solder the wire over. By the way, these things here, these clips, have some springiness in them. They have to be made of steel to have that springiness. If you make them of copper or something, there's no springiness. So this is trying to clip on and hang on, so it's steel. You can't solder to steel. So these are not soldered. These are all clamped, and over time you can get into trouble with them. You can jam solder on them and do stuff like that, and you can do whatever you can, but the point is they are not soldered to begin with. They're just clamped down, and they are a source of trouble in 2024. Okay, next tube. Same deal here. So this style of grid cap, when you rotate it, not the cap but the clip, you rotate it in one direction, it comes loose. Like a lot of things, you rotate it one way, they tend to grip. You rotate it the other way, they tend to let go. Okay. Why am I saying all this? Because no one's making these tubes anymore. I'm using a little screwdriver for it. And I don't think anybody's ever going to start up. Now that means that these tubes are only becoming more and more scarce. And I'm proud to say the thousands of tubes that I've handled, I've only smashed a few. I've only ruined a few. Maybe 15 over the years. Sounds like a lot. That's because I did 6 all at once. I blew 6 1-volt tubes in a radio, and when I was learning, I learned something the hard way there. 6 of these little 1-volt tubes. But I have dropped vacuum tubes and had them smash. Well, that's gone. Okay, so this is a 6-pin tube. A 6-pin socket up here. 78E. 78. Find that over here. '78. 6.3 JR 0235 0235 with a 4 on the end. If this is on a number and not on 0, or let me put it this way, if this is on 0, then it's a tube without a suppressor grid. Kind of just make you a little more aware of what's going on here. 24 66 grid cap. Okay, looking at the pins, 2 pins will be fatter than the rest. These 2 are fatter than the rest. There's also an arrow down here to make sure you know where these 2 pins are. The socket's designed so it only goes in one way, but push hard enough and you can get it. You can do something. Now, it's a great big cap. I'm just going to hold that like so. Okay, so this is roughly 1500 when it's new, and 1,000 when it's old. So 1,500 or 1,000. Okay, any shorts in here? No? There we go. She's a winner. Good shape. Something else I try to keep in mind, but I'm not particularly good at it, but when the tubes are hot, the filaments are looser and wigglier in some tubes. So when they're hot, if you shake them hard, you're more likely to damage them than if they're cold. Is that really true? Don't know. Don't want to find out. Okay. Sorry, I'm showing you the back of my head there. I'm very sorry about that. Okay, I think it's those two. I think it's these two. Yeah. Okay, next tube coming out. 6J5. Now that's not a very common tube, I don't think. At least it has been for me. What I discovered is that my cats, they love to play with boxes. I don't think that's much of a discovery. But you know all that paper that comes these days? We get stuff delivered and the box has paper in it for packing purposes. They love that paper. You put the two together, the paper and the box, that's what you're hearing. They'll play for ages. Throw a toy in among the paper inside the box, put the box on its side. They just love that. They love that hunting sort of thing, I guess, is what it is. Okay, I'm not going to get this much cleaner here. Trying my best not to wipe off the numbers. Bit of a cat battle going on behind me. Okay, here we go. 6J5. Over here now. 6J...6J5. 6.3 JR. 53070. 53070. So I know this tube does not have a suppressor grid. 23 and 73. Right there. 23, 73. This is 2,000 if it's like new. Just to add more excitement to the bag and paper playtime for my cats, I stuck all that into the shower stall in the washroom just around the corner here. So they go in the shower stall, there's a couple of big cardboard boxes, a bunch of that packing paper, and they are having a ball in there. And they're staying out of my hair. Okay, shorts. Okay, no shorts showing up. 2,000 good, 1,200 throwaway. So it's coming up at 1,000. It says 1,200, 1,260 actually. So let's look at the sensitivity of the bias here. Very sensitive. So, you know, this is an old machine. There's no reason to think setting this to 22 is really a proper 22, or whatever it might be. So, tube's not dead, going back in. 6J5. I don't know if I even have any of these. 6J5. Okay, I'm going to stop for a little coffee break, and we'll carry on after that. Hopefully my phone has not been interfering with the video. I just realized it's in my pocket. So hopefully you didn't hear my phone chattering there. Okay, coffee now. I thought I'd show you this peculiar problem on my house this winter. I took this photo a couple weeks ago, I guess. And this is true of all the houses, certainly around me and probably all through this area. This is the edge of my eaves trough. Normally there's nothing beyond that on my roof. but there's all this snow here. This is almost a foot. This is ice. Under here, this is thick, solid ice. And this is snow on top. This is, like I said, this is from a couple weeks ago, so it's a little different now. And you can see the icicles coming down. That's not surprising, but these icicles are coming down out of that. And I think I have another photo here. Yeah, there's a close-up look at it. So you can see the edge of my eaves trough. This is ice. You can bang this with a hammer. It's thick, thick ice. It's not coming off. Right to the edge. It's thick, thick, thick. This is snow out here that can come off. And again, this is a couple weeks ago, but it's not a lot different yet. And look at these icicles are hanging from the outside edge of the ice. So this is what's called ice damming. I've never seen it before. I've heard of it. Never seen it happen before. And that's what's happening here in my house. Jeepers. Yeah. Okay. I just wanted to show you that for fun. Okay. Ready on the next one. I'm silent because I was watching a little TV just now while I was drinking some coffee, and I have to be silent. Yeah. So a couple days ago I posted a video where I kind of did a stand and deliver video, and it's become quite popular. It's actually going a little bit viral, so that's got me a little worried. You know, typically about 1,000 people watch my videos. Suddenly there's 40,000 watching that one. It's just kind of a freaky thing. Okay, grid cap. And what tube was that? It's a 6K5. 6K5. Okay, 6K5. 6.3 JR 03070 03070 21 and 49. 21 and 49. Okay. Shorts. Nope. Okay, 1,000 is good. 630 is time to go away. So 1,000 is just right here. So it's good. It's right in the middle. Probably if there's a beneficial effect from me doing this, it's going to be from unplugging and reseating all these tubes. That's probably the biggest benefit. Hey, I did them all. That's it. I've done them all. Okay, well, there's no serious tube problem in this radio, that's for sure. I mean, if there was, the radio wouldn't operate at all, or it'd be a lot more noticeable. A little surprised at how strong the output tube is, considering how weak the volume is. But that could be really because I'm using an incorrect speaker. That could really be the source of the problem there. Okay, so what should we do with this thing then? I think I'm going to go drink some more coffee and think about that. Must be something more we can do with it today. Let's take a look at the output tube bias. A lot of these radios use a cathode resistor to create the bias for the output tube. Not this one. The cathode is grounded. So how is the grid being made negative relative to this point in the circuit? So if we follow the grid back, we see blocking capacitor going this way. This is of interest from a repair point of view. And come down here. Look at where this wire is going. It's going right to here. This is the most negative place in the radio. I think we could say that. Most negative place in the radio. the only thing that's connected to this most negative place is this line here. If we jump across this resistor, we find the connection to the chassis, the first ground. It's on the other side of this resistor. That means some voltage is dropping across this resistor. It's making this area more positive relative to this most negative place here. Chassis a little bit positive to the grid. Now we can flip that around and say grid a little bit negative to the chassis. Grid's a little negative to the chassis. Cathode's hooked up to the chassis. Grid is a little negative to the cathode. So the bias resistor is this one. It's quite a tricky arrangement here, I think. I won't say too much more than that because I think it's too tricky for me too. So the bias is not coming from the cathode resistor, it's coming from this guy. So the value of this resistor is critical. 220 probably conveys a fair bit of current, probably gets a little warm. Let's look at part number 35. Part number 35. What is the wattage? A 1 watt resistor. So this guy, we got to find this guy and make sure he's still 220 ohms and he hasn't gone off. The other thing we need to do is find this capacitor and make sure it's not leaking, and the way to do that is to replace it. If it hasn't already been replaced, which I don't think it has, we need to find it and replace it. This one is trying to stop the plate voltage over here from leaking through onto the grid. We have this positive voltage here trying to make the grid negative, and a little bit of the charge can leak through. It can build up over here. Why can it build up? Because it's choked off by this large resistor. So it's dammed up by this resistor. So pressure builds in this area, and you'll destroy the bias of the tube. The result of that is heavy current flowing through the tube all the time, heavier than intended current, and faster wearing out of the cathode. And I guess in the worst case, if this were to short rate out or just become a basically an open highway for electrons, or charge rather, then gee, I don't know what would happen, but it would be bad. That's about what I would say. First, I think the tube would be driven into cutoff. You wouldn't have any sound, or if you did, it would be really choppy. Kind of, I don't know how to describe it, but never seen that quite happen. I think it would be a disaster, though. Okay, so that's the two things. Check this resistor, change it if necessary. Check this capacitor, change it for sure. Let's start by looking for the capacitor. That's a little easier to spot. And so we have a 6F6. And the capacitor is on the grid, and the grid is pin number 5. Pin number 5. Okay, so output tube, pin number forgot the pin number. 1, 2, 3, 4. Did I say 5? I don't think so. I forgot the pin number. Shouldn't have closed my book. 6F. Maybe I should have asked my computer. That's an interesting idea. Let's see. It's pin number 5. Let's just see how modern the world has gotten. Pin number 5. Let's ask my computer here what it thinks of that.
Hey, good morning. I'm co-pilot. You can chat with me like you would with a buddy. What's your name?
Oh, you don't need to know my name. I'm working with an old radio, and I have a particular vacuum tube, and I want to know which pin number of the tube is the grid. The tube is a 6F6.
For a 6AV6 vacuum tube, pin number 2 is typically the grid. Always good to double check with a tube manual or schematic to be sure. Working on old radios must be quite the adventure.
Yeah, I'm not going to get into a conversation with you. You're a machine, okay? Let me ask again. I think you misunderstood which tube I'm talking about. I'm talking about the 6F6.
Got it. For a 6F6 vacuum tube, pin number 5 is the grid. Hope this helps with your radio project.
Yep, thanks. Bye.
Mm-hmm.
Yeah, bye.
All right, take care.
Okay, I'm going to turn you. How do I turn you off?
You can end our conversation now, and I'll be here if you need me again. Have a good one.
Whoa. How do I end the conversation?
You can simply stop talking to me, and I'll disconnect after a bit. Take care.
Okay.
Mm-hmm.
Yeah. That's definitely freaky. This is really freaky stuff. So I just basically crossed the line into the future here. And why is my video so stuttery? What's happened here?
Stuttering video can be caused by various factors. Slow internet connection, high CPU
No.
usage.
You know, I did. There's an X in the top right corner of the window, and I clicked the X. He's gone. So that's how you do it. He wouldn't tell me that, though. No, because he wanted to hang around. I don't want those things hanging around. Okay, that was interesting. So I could do that from now on instead of opening up this book and looking through it and all that kind of stuff. Just ask the machine. The machine knows all. Pin 5. Okay. I'm so kind of freaked out by what I just did. I really just think about what I just did. I talked to a machine like it was a person. Oh my gosh. We're all going to be doing that. And maybe I'm late to the game, in fact. So, okay, pin 5. So come down here. I count 1, 2, 3, 4, 5. Okay, so this is 5. And guess what? This capacitor is on pin 5. It's a 0.01. It's the correct type of capacitor. This is a pretty reliable style of capacitor. How can we find out if this is causing a problem? So we look for some. We gotta find that resistor next. But there is a way. We can simply measure the voltage of the grid using a very high impedance meter and find out if it's being pushed positive by this. Now where's that resistor? So the resistor, that could be almost anywhere. It's better to find that by its size. It's a 1 watt. Yeah, come on, Bert, give me a hand here. It's a 1 watt. Oh, right off the keyboard there. He's in, he's out. That was quick. That's just a kind of a blow through. Right, the resistor. There's a high wattage resistor right here, and that's brown, green, brown. That's 150. I'll bet you that's it. I'll bet you that's a replacement, and that's all the guy had. Any other high wattage resistors in here? I think the answer is no. Generally, they're going to put them a little bit in the open. That's the only high wattage resistor in the whole radio. That's got to be it. So, where is it? So it's connected to the negative. Well, there we are right there. It's connected to the negative of this capacitor. And that follows the schematic. So this should lead back now to the center. No. This leads back to the center tap, and that's probably this wire here. And this leads on to the rest of the radio, causing the radio to be elevated, and also the radio chassis and the whole radio to be elevated in voltage over the center tap, most negative point. Let's measure the resistance of this guy here. Now it's in a circuit. It's in a complex circuit, so I don't know if this is going to be valid or not, but let's see what we get. 150. $254 ohms. So this resistor has to be at least 254 ohms or more. Well, that's a problem. So that you know what this would do? This would raise the voltage drop here, increase the bias of the output tube, making it much more negative, and then quieting the output tube because of the high negative bias, resulting in low output volume. Yeah, that all hangs together. Probably not true, but it hangs together really nice. I think we should make some measurements in here before I start fooling around, just to see if my theories have any, hold any water or not. So considering where the world's heading, I thought I better get this chat thing just ready to go all the time. So when I'm working in here, and it's still stuttering, I wonder why. Anyway, so I went to do that. I went to set it up so this the Microsoft AI would be available just as soon as I spoke, and I went to turn it on, and here's what the screen says. Oh, if I can find it. Hope I can find it again. Sign up to talk more. I'd love to keep talking. More time is available when you sign up for an account. I already have signed up for an account, but I guess somehow it's not active on this computer. I'm not going to worry about that anymore. But there you go. They give you a little taste, and then pay me now to get more. Actually, you don't have to actually pay anything, do you? So, right. What am I doing? Oh yeah. Right. What am I doing? I'm going to turn this radio on, and we're going to measure those voltages. Now, I was going to use my vacuum tube voltmeter. I have this one over here, and that's a 10 meg input. It's probably the same as this. This is probably a 10 meg input impedance. But I have a really good meter over here, just sitting here. This one here. This has 110 meg ohm input. So that would be the ideal meter to use, but the problem is it's a vacuum tube voltmeter, and one of the leads is grounded, or is potentially grounded, I'm not really sure, grounded through the hydro system, and I don't want to involve that in this while I'm doing these tests. Not every test is to the chassis, so I'm going to use this meter because it's just completely isolated, battery operated meter, and I cannot make the mistake I'm concerned about, which is sticking a ground on in the wrong place. So okay, so we're going to look up once again, what am I doing? What am I doing? I don't need this, do I? I don't need this. I know where the parts are. What we need to do is turn it on. We need to turn it on. Turn the volume down. The speaker is not connected. That's not going to work out. That's not going to work out. Let's get the speaker. And once again, how lucky am I that I'm able to just plug this guy in and get somewhere. I thought that was going to be a huge hurdle. It would require jumping, but no. I'm not going to hide my book. The book. Close the book again. Okay, let's get the radio going here. Volume is down. Dim bulbs in. Normal behavior being seen. Give it another moment. Okay. Hook them right up to Niagara Falls here. We should look at what the recommended bias voltage is for 6F6. Bit of a hum coming out of the speaker there. 6F. Crazy cat action behind me all the time. Come down here to typical operation, and we go down grid number 1, control grid, typical bias with fixed bias. That's what this is. This is fixed bias. Minus 16 volts. A little higher B plus, minus 20. So it's a big voltage. Minus 20. That's a lot. So we're looking for something like that. 15, 20 volts. What is dropping across that resistor? Well, 20 volts. Not really a problem. We're at 109 supply volts, so that is the bias. Well, okay. Now, what's on the grid? Now, the thing about taking this test is I want to look between chassis and grid. I'm really looking between the cathode and the grid, and I want the grid to be negative by that same voltage, which it almost certainly will be, won't it? And the grid is this terminal here, and then the chassis is here. Now we get minus 18 volts. Hard to complain about that. Reading the voltage across the capacitor doesn't mean much. I think the bottom line is everything's okay. Surprising to me. Kind of expect this capacitor to leak, but you see it's already been replaced. Somebody's already replaced it. And why the resistor is the wrong size? My guess is that's what the guy had, so that's what he used. And turns out it works okay. And what that also means is that there's no risk to the output tube in operating this radio, which is one of the things I wanted to clear away fairly quickly. In some of these radios, the output tube is cooking until you correct these things I've been looking at today. And you cook away an output tube. Output tubes are scarce for this very reason. They wear out. So let us not be responsible for premature wearing out of the output tubes, because God knows the world needs its output tubes. Okay, I think that might be it for today. Yeah, I think I'm going to cut it here. Tube's okay, output tube's okay, operating the radio appears to be not a bad thing to do, so I can continue fiddling around with it. Hey, why don't we fiddle around with it? Yeah, I'm going to hook it back up, because last time we tried playing this, it didn't play. Let's try it again. Yeah, that's what I'll do. Well, I did go ahead and log into my Microsoft account here on my computer, so we're just going to try this guy once again. Copilot, you there?
I'm here, Jim. What's up?
Can you tell me again, what is the proper grid voltage for a 6F6?
Sure. For a 6L6 tube, the typical grid bias voltage range is around minus 30 to minus 50 volts. Always best to check the amp schematic for the exact value. Working on something cool?
I think you misunderstood me. Not a 6L6, but a 6F as in Fred 6.
Got it. For a 6F6 tube, the grid voltage can vary depending on application, but a typical range is around minus 3 to minus 5 volts. Always a good idea to check the specific circuit requirements. Working on a vintage radio or an audio project?
I don't want to talk now. That's what, me, I like to talk all the time, and now I got this thing on beside me, and I'm afraid it's going to start talking to me at any moment. So it says 3 to 5 volts. Hey, he's listening to me. 3 to 5 volts, but my book says, hey, hang on, my book says minus 16 to minus 20 volts.
Minus 16 to minus 20 volts makes sense for certain setups, especially in power amplification stages. Your book should be a reliable reference. Working on fine-tuning your project then?
Copilot, I'd appreciate it if you don't ask me questions.
Got it, Jim. No more questions. Just here if you need anything.
Thanks. Wow, I'm freaked. My hair is standing up on my arms right now. I am so freaked out by what I am doing. This is Hey, no, please don't talk. Because I'm not talking to you, Copilot. It take a little while to learn how to actually live with something like this, which is it's coming at us in gangbusters in every direction. This is what our lives are going to look like. So my experience with this so far, the talking thing, you're seeing me do it for the first time, but using AI, it's been fantastic. It really has. It's like you have an expert in everything right there with you, who's going to help you out. And the only thing you got to be careful about is it's wrong quite often.
Absolutely. It can feel like having an expert at your side, but it's key to stay critical and double-check important info. AI is a tool, not a substitute for your own judgment. What's been the most surprising thing for you so far?
Well, the most surprising thing has been that I'm trying to not talk to you, but you keep trying to talk to me. So there's other people in the room here. So you're not quite clear on who I'm talking to. And I guess that's understandable because you're not here to see who I'm talking to.
I understand, Jim. I'll stay quiet until you need me. just let me know.
And the hair stands up again. This is weird because I'm totally alone here. There's nobody here, but it sure seems like there's people looking over my shoulder. That would be you. And there's some guy in my computer now trying to talk to me. What a weird world. No, I didn't ask you to say anything, Mr. Copilot. What is your name, Copilot?
I'm Copilot, your AI companion from Microsoft.
What should I call you when I want to address you?
You can just call me Copilot.
Okay, Copilot, please be quiet.
I'm right here, Jim. What can I do for you?
Be quiet.
You're welcome.
No, don't say anything.
Uh-huh.
I think the problem here is that he likes to talk and I like to talk, and you know, we're both looking for every opportunity to talk. Come on, cat. Oop. Okay, confusion all around, so I'm just going to click this red X here, and Mr. Copilot's gone. Right? You're gone, right? You're not listening, are you? Well, he could be listening now. He's just not going to let me know. Wow, what a strange thing. This is still on because I was going to try to use it. Yeah, that's right. That's right. So I hope you're getting a kick out of what I'm doing here, regardless of the radio side of it. Okay, so I got it. So this should be connected now to an outdoor antenna. Let's turn this up. That's a very good sign. Put the ground on the ground. That's funny. Gets quieter. Okay. Volume up. We're on. The dial button's pushed in. I don't know what band we're on. And the radio is not responding. Right back to where we were. Supply voltage is 109. I'm going to jack it up just a little bit. Get her up to 115. Can't complain about that. And we still have no action. Let me check what band I'm on here. Find my pair of pliers. Yeah, so I'm on the broadcast band. Well, something wrong here. I think I'm going to leave it at this for today. We know it's not the tubes, and or not likely to be the tubes. I did put all the caps back on. Yes, I did. Yeah. And why do we do this? What's the B plus in this radio anyway? Here comes Bert. Watch it now, Bert. Because we're running at 115 volts on the line, and the go this way. I don't want you right around here. Just see your tail. I'm gonna get your tail in something. Here we go. Cat away. There he goes. Oh, for God's sakes! Oh yeah, B plus. I forgot what I was doing there for a minute. 600 volts. Between what's on this capacitor here. There we are. 282. Okay, and then on this other one, so this is the output side. Should be a little lower than the input side. Let's see what we got here. That's pretty high, 356. So 350 volts on this capacitor. That's an important thing for me to know if I'm going to replace it. I believe it's a 450 capacitor. I don't want to put my finger in there right now and check it out. Okay, that is it for today. I am done. Gonna go have some fun with Copilot. The most fun thing, I'm really looking forward to this, frankly, is having a talk with him about philosophical things or things that really bother you in some way you've always wanted to know and never could find the answer to this very pointed question, then it may not have the answer, but it may help you to work your way to the answer you're after. And it's conversational, you know, just like I'm doing now. We're in a new world, and I'm pretty sure there's another new world coming just down the road, and another one after that. Thanks a lot for watching, and see you on the next video.